Hello guys, in this video we're going to learn how to make a Flask web application that would inspect HTTP requests, and here on your screen you can see how the end result is supposed to look like. So I've added this new feature of inspecting HTTP requests to my web scraping Kung Fu site, and it consists of two parts. The first is the UI itself, which you can see now on your screen, and also it fetches the data from the API that actually handles the incoming requests. So if you're interested in creating this sort of an application, let's actually start writing some code. So here I have created a new folder, inspect respects, and in the current working directory I have empty app.py file. So now we need to import a bunch of stuff from the Flask module in order to achieve our goal. So we can simply say from Flask import. We will need the Flask ourselves to create an app instance. We'll need also request in order to inspect requests. JSONify would be needed to create the API, and also we'll use render template string in order to avoid creating a templates folder with a corresponding template to return for our user interface. So we'll be simply creating all the app in this single app.py file. So now let's create an app instance that would be equal to Flask, and the argument here is name like this. Now, so we need to create a couple of routes. So the very first route would be the root route. So let's create the callback function for it called root, and for now let's simply return a string notifying the user that this is basically the root route, and also app.route and /API. So this sort of employee would be responsible for our API for our application. So def API and return API for now like this, and let's provide app driver here. So I say if name equals to main. In this case we want to start our app by saying app.run, and we also want to enable debug mode by specifying debug equals to true, and also it would be nice to have our app multi-threaded, so I say threaded equals to true as well. And now I need to invoke terminal in the current working directory and simply type python3 app.py in order to start the development server. But default, the Flask starts the server at the port number 5000. So let's go there and see what is there actually. So here we have our route being handled correctly, and let's check out the API. Okay, so the API is correct as well. And now let's actually start inspecting our request. So instead of returning API, we can simply return well, let's first create the data variable here, and here we'll return JSONify. JSONify is a nice built-in method of Flask that allows you to pre-print the API within the browser. So it's pretty similar to JSON dumps, the standard function of Python, but it also alters response headers, so you can see indentations when you're watching your API. But at some point at Heroku it's not really it doesn't really work, so you have a bunch of stuff here, but in our application we would have a pre-printed API. So here let's specify the data itself, and now regarding the data we'll need the following parameters. So first let's consider our API, and by the way, so let's create actually an API variable, and here is the reason why I'm not using a remote request.remote address directly. Well, that's because it depends on where you're supposed to deploy this app. If you're deploying this on some sort of Amazon Web Server instance or something like that, it would probably be fine just to use request.remote address. But say at Heroku, in order to obtain the real in order to obtain the real IP address, you need to reference x forwarded for header instead, which contains the real address basically. So just grab this stuff here, and I simply say here that if request dot headers dot get list, and here specify x forwarded for. So in this case, IP would be equal to basically this. Would be equal to this kind of stuff. Copy, paste, and we want, as far as the get list function returns the list, we want to reference the very first element of it. And in all the other cases, else we can simply say IP equals request dot remote address. So in case of our application, we won't be hitting this part, but if you would like to deploy this sort of app at Heroku, you would definitely see absolutely the same result as I have here in my app. So let's actually try to test this first. So just update the API. So now we have the IP address, and of course my local host is shown here because I'm referencing this kind of app from the local host. Okay, and the second thing to consider is actually when to print the URL. So URL would be equal to request.url, and also, okay, so just let me quickly check that out. What else? So IP. Okay, so also we need the method, IP method, URL, and the headers. Okay, so IP, and here specify the method would be equal to request dot method like this, and here we can simply specify our headers. That would be equal to request dot headers. So I just save my app and try to update. So okay, something has gone probably wrong. Okay, headers. Oh, of course, colon instead of the letter there. Okay, so just update my stuff. Environment headers is not JSON serializable. Okay, guys, just hold on a sec. Okay, so this error is arising here because the request.headers is actually a list of dictionaries. So if we just enclose this into the square brackets, this time this would be the type of list, and now it should work just fine. So let me just quickly check that out. Okay, it still doesn't. Why? I'm sorry, guys. Not like this. And instead, we need to convert this headers to Python dictionary. Okay, so really sorry. So now this works just perfectly well. So here we have our headers. Well, some of key ordering is applied by J75 method by default, but that doesn't really matter that much. So basically we have our headers, API, and method, and the URL. And from now on, we can actually start building our user interface to present this sort of data in a more pretty way. So before we start building user interface, let me just quickly copy this HTML template to our project. So now we'll be working here within our root directory. So here we can simply return render template string and use the template variable, which we will create just right in a moment, as the argument. Okay, so here we specify our template variable, and we'll use the multi-line string here, and I just paste my stuff. Okay, so good. Okay, so now just let me specify the indentation equals to 2 spaces, because I used to work with the 2-space indentation when dealing with HTML files, so just bearing that in mind. Okay, so we don't need together. Let me just get rid of that one. So we don't need data tables either. We would be just using the plain jQuery table, the plain HTML table powered by Bootstrap, and also we don't need 5-icon here as well. So let's just save this stuff, and now I'm going to the route here. So okay, nothing to see, but that's pretty fine. So well, let's specify probably the title. Okay, so HTML head. So let's specify the title, inspect HTTP requests, like this, title. So okay, now we got our title working, and here within the body I would like to create a couple of nested cards, this which references the bootstrap card class. So I can simply say div class equals to card and close the div tag, and also div class equals to card body. Okay, and closing the div tag one more time. Now I just want to make it nested to have somewhat nice cute borders. Okay, so let me just see whether it works. Okay, simply needed to update my browser correctly. Okay, so here we'll create a couple of tables. So the very first table would be responsible for the request related stuff like IP address, method, and the URL, and the second table would be responsible for headers respectively. So here's our first table, and we don't need headers there, so we would be so I'll provide them just manually. Okay, so first let me create table body here. Okay, table body, and also I will provide the very first table row to specify what we're supposed to do in this table basically. So table data. I could have done this within the table headers, but I just don't really want to do that. That's far too complicated. Okay, so this would be so how will we have in my initial implementation this? So we have requests and the headers. Okay, so here we have requests, save, and just update. Okay, and now so we also need to add a couple of classes here. So we have the borders around, and the background color is white. So yes, class equals background light, and okay. Oh, so the table should be the class equals to bootstrap table here, and also we want to write the border around our table. Okay, yeah, now it seems like what we want. And also probably here in the table we want to specify the text center. Oh, maybe just trying it here, text center. Okay, no, not exactly. Okay, hold on guys. Okay, just needed to update my browser a couple more times now. Okay, so and here after this sort of table row, we will be using jQuery dynamic rendering, dynamic HTML rendering. So here I just specify jQuery dynamic HTML rendering like this. So okay, before working on the second table, let's actually first deal with filling our first table with the data. So here let's specify the script, and the type equals text and JavaScript like this, and closing the script tag, and Okay, so the very first thing to consider here is actually we need to make a GET request to our API. So in order to do that, we specify this $sign calling the jQuery object jQuery.get and /API, and in case and as just to handle the response here, because this kind of stuff is done asynchronously, and here I'm using the arrow function definition, which is the shared function definition in JavaScript, and the argument that would be taken by this callback function would be actually the data itself. So here we can simply say console.log and specifying our data, just to make sure that this jQuery script did successfully fetch data from the API we've provided before. So I need to open my developer tools to see the console. If we just update this stuff, okay, so here we get our response from the API, so our headers, and also IP method and the URL. And now regarding this request table, we don't really need to deal with the headers, so we need simply to iterate over the entire response object, and we'll just ignore the headers and use this IP and method and the URL. So it's easier to show rather than to explain, as always. So here we can simply say, so jQuery has a great each method that allows you to iterate over objects. That's something similar that we can do in Python basically. So the first argument I'll provide here is the data itself basically, and the second is the callback function that would be taking two arguments, the key and the value. And here that's actually trying to console.log, and well, let's try to log our keys, save, and I'll just update this stuff. Okay, so here we have our keys and here we have our values respectively. Okay, okay, here we have our values, but actually now we need to say that if key is not equal to headers, so in this case console.log, let's have our val again, save, and headers is not defined. Oh, should it be the string value? Okay. Okay, so now we iterate only over our IP method and the URL. So from now on, what we actually need to do is to render our table dynamically. Let's create a row variable that would be holding the HTML code for entire row that we're supposed to append to our table. And also, in order to do that, we also need to specify the ID for the table body here. So I can simply say ID equals to, so this regards request, so let's call this request like this, store, and here let's create the row variable that would be equal to, so we need to specify the table row and close the table row tag, and also, okay, just hold on. Sorry, just, okay. So table row, and here we'll have the two table data tags. So table data, and close the table data, and also another table data. So here we'll need to add a key, our key that we're iterating over, and also we want probably this colon sign here, and here we would like to append our value, and also I need to select our request table body using the jQuery selector like this. So I'm using the hash symbol to reference by ID. So ID request, okay. So reference and request, and then simply say dot append and specify the row here. So let's see what we'll get. Okay. Okay, so now we get our IP, method, and URL. And now to make it a little bit more pretty, let's make this sort of values a little bit more bold. So in order to achieve that, I can specify the extra strong tag here. So saying strong and strong over here. So okay. Okay, so now we have these guys. So the next thing to consider. Oh, okay, guys. So I've just seen that I missed one more table data in the header. So if we simply specify another empty table data here, this bug should be fixed. Okay, now it's fixed. And now let's basically create the second table containing our request headers. Well, probably request headers, exactly. Now the response headers, yeah, just request headers instead. And by the way, yes, I also realized that we don't really need even these guys as well. So okay, and also, yeah, so now let's basically create a new table here. So this would be almost the same, but so just to make things a little bit more clear, let me comment this stuff as request info, and here we'll have headers info. Okay, right, and paste this. So here we'll say headers instead of request, and also I need to change the ID to headers like this. Okay, let's see what we got. Okay, we got our headers. So now let's dynamically append elements to headers, just exactly the same way as we did for our request stuff. So here it's almost like the same code, but okay, let me add a couple more commentaries. So append rows to request table, and this would be append rows to headers table like this. Okay, so here we want to iterate not over the data but over the data dot headers, and here we'll specify headers instead of request. So let's try to see what we'll get here. Okay, so it seems like it almost works. The one last thing, I have no idea what happens, so why the headers is not actually located in the same place as the requests. Let me just quickly find that out. Okay, so to make it a little bit more look like the original, that's actually, so it still has a little different layout compared to what is in my app for some reason. So let's try to get rid of this text center within the headers and within the requests as well, and try to see what we're supposed to have here. Okay, so we have our headers and requests. Great. And also, well, we can make them strong as well, so let's probably try to doing that. So strong like this, and also the same here for headers. Okay, now it looks like much better. Okay, also I want to have a slight a slightly more space between our tables. Okay, so this is slightly better now. Okay, so the very last thing left here is actually I want this URL to be clickable. So in order to do that, let's go to, so where is this? This is the request related stuff. So let's go to where we iterated over the request. Oh, by the way, guys, so we also don't need this sort of condition because key can take the value of headers within the headers itself, because headers are only like accepting coding, blah blah blah, etc. So no kind of headers there. Okay, and also, so here now we need to say simply if key is equal to URL. So in this case, what we want to do, so just copy this for a while, and here say else, and so here we want actually to add a little more tags here, so a tag to be exact. So where is the value? Okay, table data. So here we specify the a tag, and let's close one. Okay, and also specifying the h reference equals to okay, equals to, and here we break the string and append the value. Okay, so let's try to update this stuff here. Okay, and okay, so now our link leads exactly to the API endpoint. Well guys, okay, so it seems like this is it for this tutorial. I hope you learned something interesting out of it. So basically, until the next time, and take care.